Hey guys, this is Devika, and this is my project on Henry Cavendish, an English chemist and physicist. It is his birthday today, October 10th, the day I'm filming this, and let's wish him a very happy 281st birthday. Henry Cavendish was born in Nice, France, which is here by the Nice A Google Maps has provided for us, and that's far away from London where his family lived, and that's where he was brought up. And that is because his family is extremely wealthy. He grew up in an aristocratic family who could afford to take vacations and buy many houses. And when he was 40, his father died, so Cavendish, he inherited a massive fortune. By the time he died, Cavendish, he was one of the most wealthiest men in England. And in his childhood, he attended Hackney Academy in London, prep school, and that allowed him to go to Cambridge University, which he stayed for maybe 3 or 4 years, and he dropped out at the end, which was common for the time period. Not many people got degrees, and straight out of university, he made himself a nice laboratory to experiment in using his father's money so he could pursue scientific studies. One of the most interesting and unique things about Cavendish is that his personal life was non-existent, really, because he was so immersed in science and physics and chemistry that he lived in the laboratory that he owned, and he had no social life. You know, he was very shy, eccentric, and antisocial. He never married anyone. He was a bachelor all his life, and he did not have any friends except for his scientific colleagues who would talk to him about science here and there. And he was so antisocial that he communicated with his servants through note writing. He could not talk to them, he would write them notes. He was that shy. And he did not bother to publish many of his works, Cavendish, and that's unfortunate because he was advanced for his time period. Many scientists were not thinking on his level yet, and if he had published some of his works, which I will talk about later, he would have gotten a lot more credit, and he did not do that. Professionally, Cavendish was meticulous, tedious, all that. It was great. And he immersed himself in scientific studies. He joined the Royal Society for Improving Natural Knowledge, just known as the Royal Society in London, which is why he has an FRS at the end of his name sometimes. And that was the only society or organization he would go to, just this one for listening to scientific discoveries. He published maybe 20 articles throughout his career. He did a lot more experiments than that, but he just didn't bother to publish them. He did a lot of research, and he worked with these scientific organizations. He was known for his accuracy and precision. A lot of his work was very tedious and well done. He was known as a pneumatic scientist, which is just a fancy term for scientists generally who lived in the 18th or 19th century like he did, who worked with molecular chemistry and gases, which moves me on to his major works, part 1. As a chemist, Cavendish did many important things. For the first one, something huge was that he discovered hydrogen. Well, he called it inflammable gas, but it was actually hydrogen. And what he did to discover hydrogen was that he put zinc in hydrochloric acid, which you may have done in chemistry, and that produced hydrogen. And in 1766, he published his work Factitious Airs, which was basically a study of gases he had done, which was, again, meticulous, tedious, and it just characterized gases. And his style in chemistry was or anything really, was to use quantitative measurements to compare gases and things as such, which means that he established hydrogen, for example, as a different gas because it had different density than the other gases. So that was kind of unique. And something else Cavendish did was that he discovered Ohm's law 50 years before Ohm did. He did not publish his results, and that is why it's not called Cavendish's law. Ohm's law relates to electricity, and it can be characterized with this triangle shape, and it means voltage equals current times resistance. And the way Cavendish figured this out is really one of the most unique stories in electricity and scientific studies. What he did was that, Cavendish was experimenting with jars and tubes of different diameters and length, and he filled them with salt solution. and then he measured the current and the voltage by how much of a shock that he experienced. He measured the voltage by his pain, which was really, eccentric. So that was something interesting that he did. And again, he did not publish his results of this experiment, and that is why he did not get credit for discovering this important theory of electricity. Probably the most important experiment that Cavendish did was the Cavendish experiment, or sometimes called the torsion bar experiment, which was from 1797 to 98, and that put Cavendish in his 60s. He was getting kind of old, and this was probably, his last amazing major work. And this experiment is so important because it is the first experiment to measure the force of gravity, or, we like to call it the forces of Earth, between masses in a lab, and it was extremely accurate, actually. His values were not improved on for 100 years, so this guy, because of his tediousness and meticulousness in experiments, that is how he was so successful. So what this experiment actually measured was the density of the Earth. It expanded on Sir Isaac Newton's theories of gravitational constances, which was not touched upon until Cavendish came along and did this experiment. Now this experiment is kind of detailed and long, so I'm just going to give you a really quick fill-in. So basically what Cavendish did was that he took this is actually a model, and it's not to scale, it's huge, the thing is huge, and he put it in a field outside his laboratory or somewhere near a shed, and then he stood from very far away because, his gravitational force would interfere with this model, so we had to stand from, a distance and look at this through a telescope. And what happened was that these are lead balls, these two right there, and they attract each other due to the forces of gravity, and then what happens is that the torsion fiber starts to twist and move, and this mirror here also catches the light as the fiber twists and move, which creates, an angle. It says 26 or 28 here, and Cavendish, he used that angle to somehow get the mass of the Earth, which was really something great and advanced for his time period. Now, because Cavendish, lived a life of a recluse and he was not present in society, even though he was extremely wealthy, he lived, a life alone and he died alone. And his legacy, although not many people know him because he did not publish his work, was that Cambridge University actually honored him, and they made the Cavendish Laboratory, which is their Department of Physics, and it's a teaching laboratory, and it's very famous. 29 researchers have won the Nobel Prize because of their work at this Cavendish Laboratory. And that concludes a really quick run-through of the biography and work of George Cavendish, an English physicist and chemist, a brilliant mind who was just socially awkward and did not get the appreciation and respect and honor he deserved because, as you can see, he did a lot of work.